Good morning to class 12 students. This is your chapter 3rd, electrochemistry. We already finished our first and second chapter. If you have any doubts, you can write in our comment section. Okay. And you have to note and solve each and every exercise that are provided at the backside of the last slide of the lecture along with the dates in your notebooks. Okay. So today I start chapter 3rd, electrochemistry. This is your introductory part about the types of cells and cells. So what do you think about the electrochemistry? Electrochemistry is basically a branch of chemistry that deals with the interconversion of electrical energy and chemical energy. See the definition of electrochemistry, the branch of chemistry which deals with study of interconversion of electrical and chemical energy and vice versa. That means chemical energy may convert into electrical energy. Okay. So what do you think? These conversions are carried out by special device called cell. Cell is a device which converts electrical and chemical energy and vice versa. That means cell can convert electrical energy into chemical energy or chemical energy into electrical energy again. So on the basis of their working, cells are classified into two categories. First category represent the cell which convert electrical energy into chemical energy, and such type of cells are called electrolytic type of cells. You can see here electrolytic cells. So those cells which utilize external source of electricity to carry out chemical changes or to carry out redox changes. As similar, another category of the cell which convert chemical energy into electrical energy. That means those cells which produce electrical energy by using chemicals reactions. And what kind of reaction? Chemical? These are redox type of chemical reactions. That is reduction and oxidation. Okay. So basically there are two kinds of cells. One is electrolytic and electrochemical type of cells. We discuss the definition of both the cells. So you know something about the electrolytic and electrochemical type. In the world, electrolytic cell is the one of the electrolytic cell is known by only a single name, that is electrolytic cell only. While in case of electrochemical cell, it have various different forms. It may be pronounced as a Daniell cell, you know? It may be named as a Lagrange cell. It may be named as a lead storage battery. It may be galvanic cell. It may be voltaic cell. It may be uh, Daniell cell. So electrochemical cell has different forms according to use. Can you guess? In our house, there is electrochemical cell that we all use in our day-to-day life. So these electrochemical cells can be known by the common name that are called uh, pencil cell. So pencil cell is a type of electrochemical cell because pencil cell provide the energy, electric energy to the remote. Okay, so you may see the wristwatch. Wristwatch may contain a small circular cell that is called mercury cell. Your wall clocks are also having cell. Okay, so these all kind of are called Lagrange cell. At your home, you have all are having inverters and for the emergency light supply. So That inverter may attach to the lead storage battery to store the electricity. So these are the various types of electrochemical cells. So we are surrounded with these electrochemical type of cells. Okay, so cells are of two types. One is electrolytic and electrochemical cell. Okay, so if we see the electrolytic prototype of this electrolytic cell, a typical example of this electrolytic cell. So diagram of the electrolytic cell you can see here. In case of electrolytic cell, both the electrodes are dipped inside a common container. While in case of electrochemical cell, there are two separate containers for each electron. Okay. The second difference is that there is a no salt bridge because both the electrodes are dipped inside single container, while there is a salt bridge to connect these two cells, half cells. Third difference is related with their polarities. You can see here anode in electrolytic cell is positive, while in case of electrochemical cell, anode having polarity negative. This is your anode having polarity negative. This is your fourth difference. Now, the fifth difference is that these two electrodes are maybe made up of same or different elements or material. Okay, you can you can use graphite, both the electrode made up of graphite. Okay, there is no problem if you're using the same or different type of material to made anode or cathode. While in case of electrochemical cell, both the electrode must be different, must be of different element. You can see here in case of Daniel cell, there is a zinc. One electrode is made up of zinc, while another is made of copper. Why we need different type of electrode here? Because this electrochemical cell undergo redox reactions only if the reactivity of both the elements is different. If we take both the electrodes of made up of same element, that is zinc and zinc, then how we achieve this redox type of reaction? That is how we achieve how we achieve the reduction and oxidation. So we have to take different electrons all the time in case of Danish or electrochemicals. So we discussed the basic differences in between electrochemical and electrolytic cell. I repeat once again. Electrolytic cell convert electrical energy into chemical energy, while electrochemical cell convert chemical energy into electrical energy. Second difference is that both the electrodes are dipped inside single container, while in case of electrochemical cell, both the electrodes are dipped inside separate container. Third difference, both the electrodes are made up of same or different material in case of electrolytic cell, while in case of electrochemical cell, both the electrodes must be made up of different elements only. Okay, fourth difference is that polarity of anode is positive and cathode is negative in case of electrolytic cell, while polarity get reversed in case of electrochemical cell. Fifth difference is that there is no solid bridge to connect two half cells. Even two half cells are not there in case of electrolytic cell, while electrochemical cell contain two half cells and both are connected internally with the help of this solid. Okay, you can see here These are the basic differences between electrolytic and electrochemical cells. Now we uh, study electrochemical cell in detail. The simplest type of electrochemical cell is called Daniell cell. Why this cell is named so? Because it was first prepared by Daniell. Daniell was the scientist who prepared the cell first. Not all cells, electrochemical cells, are called Daniell cell because electrochemical cells may vary with electrode to electrodes. Okay. While in case of Daniell cell, if we say Daniell cell, then anode must be made up of zinc, while cathode must be made up of copper. Not the other elements like silver, gold, copper, etc. Okay. So if we using zinc and copper electrode, only that time we can call it Daniell cell, not in other way. Okay. The another important things to note here that the electrode used in the container must contain the aqueous solution of salt of that metal. You can see here zinc is a here the electrode is made of zinc. So we have to dip this electrode inside the aqueous solution of zinc sulfate only. While there is a copper as an electrode, so we have to fill this solution, this container with the help of aqueous copper sulfate solution. Okay. Now the importance to take a different type of electrodes that because there is a comparison between reactivity. You can see here there is a zinc and copper. Zinc is more reactive than copper. How we find the reactivity? In class 10th you have a reactivity cell here. So zinc is on a higher priority. That means zinc is more reactive than copper. So it is a phenomena in the redox chemistry that the element with the more reactivity first undergo oxidation. Must undergo oxidation. That means first zinc undergo oxidation. Okay. By the oxidation of zinc, that Zn is dissolved inside this solution and will release as Zn2 plus ion. Along with the two electrons, that electrons are continuously accumulate on this electron. You can see here these electrons are accumulate after some time on this whole electron because these electrons are not going to this solution. As the electrons accumulate on this electrode, electron density on this zinc electrode will increases. Okay, and this is a rule of nature that everything is moving from higher density to lower density. So on the behalf of concentration gradient, that electron on a zinc side having higher density is try to moving towards the copper electrode that having minimum electron density. Okay, so the direction of electron is from zinc to copper along this metallic wire. Along this metallic wire that was shown in your screen with the help of green color. So this metallic wire carry the electron from zinc to copper. As this as these electrons moving from zinc to copper, there is a production of electricity in just opposite direction to the flow of electron. This is a rule of physics that the direction of flow of electron is just reverse to the direction of current. So due to motion of electron, there is a generation of electricity. Okay, so this galvanometer shows the deflection in that direction. Okay, you can see here. So what kind of reaction is carried out? These electrons are reaches with that electron and carried out reduction. These two electrons are come from that zincs along this metallic wire and utilized to carry out this reduction. The gaining of electron is called reduction. That copper 2 plus ion gain 2 electron and convert into copper solid. That means copper deposited over this electrode, while this zinc electrode is going on thinning. Its thickness is gradually decreases, while the thickness of copper electrode is gradually increases due to deposition of copper. As similar, there is a oxidation in half of the cell. The zinc solid is dissolved into solution and forms Zn2 plus ion, that means diphosphate cation, and releases 2 electrons. That 2 electrons are accumulated on this. Later, they transfer to the copper electrode and carried out reduction here. So loosening of electron is called oxidation and gaining of electron is called reduction. So both are respective in nature. If there is oxidation, then there must be a reduction. If there is a reduction, then there must be a oxidation. That is the rule of redox reaction. In this manner, this Daniell cell works. Okay. As the time passes, that zinc electrode thickness of that zinc electrode is going on decreasing. After some time, this zinc electrode that is completely dissolved inside the solution, and the reaction will stop. And there is no production of this electricity. Okay, so what do you think? How much voltage of electricity were produced by this Daniell cell? So the answer is 1.1 volt. That was given by Daniell cell. That is given by Daniell cell. Okay. So there is a trick to learn the uh, data of the Daniell cell. You can see here lone. L means left. We consider this salt bridge as a reference. Okay, so if you draw an arbitrary line here, so this is your left portion and this is your right portion. So L for left, O for oxidation. You can see here the left half cell there is an oxidation process carried out. So left oxidation, and you know that the electrode where oxidation is carried out is always must be anode. So left oxidation and anode carry a negative charge. So lone represent left oxidation, anode and negatively charged. As similar, you can see a right reduction, cathode and positive charge. So this is all are about the cell. Come to the next. Now we talk about the cell represents that it is not convenient to draw this Daniell cell again and again. So for our convenience, draw this Daniell cell by in such a manner. First, you have to draw two vertical lines, two vertical parallel lines that represent the salt bridge. Okay, that represent the these two vertical parallel lines represent the salt bridge, and the portion which is present here is the left portion and there is the right portion. So this is your left side and this is your right side. So we have to write the oxidation first and then reduction first. You can see here. So the representation of a Daniell cell in a single line. First you have to write the reaction carried out in a oxidation of cell. Then you have to write the reaction that carried out in a rest of the reduction of cell. So you can see here there is oxidation and there is a reduction. So this is a cell representation of Daniell cell suggested by IUPAC. Come to the next. There is a question that what is a salt bridge? The salt bridge is a U-shaped, inverted U-shaped glass tube that filled with the non-reactive electrolytes like KCl, K2SO4, okay, then potassium sulfate, potassium nitrate. These all are non-reactive electrolytes called solvents. Okay, and what are the function of these solvents? So basically, there are two functions, two or three, but I just mentioned two functions only. It maintain ionic balance in both half cells or maintain electrical neutrality. And second one, it connect two half cells. You can see here the diagram. It connect two half cell internally. You can see here. This is oxidation half cell. This is reduction half cell, and it connect two half cell internally. So these are the two functions of solvents. Come to the next, output over Daniell cell. By studying this Daniell cell, we find that Daniell cell gives us 1.1 volt, and it may be used to produce potential difference of 1.1 volt. That how it come? You can see here. What is the calculation behind this output voltage of Daniell cell? Basic formula to calculate electrode potential, that is E cell node. Sorry, by mistake there is a node here. This is your standard sign. Finally, this is a basic formula, that is redox. Okay, red minus eox. So this is a electrode potential of reduction half cell. This is electrode potential of oxidation half cell, and these are having values. These are having values. These are having values plus positive 0.34 volt. These values comes from your book. Your book contain reduction potential series. You can pick up the value from that. The questions is come into examination, then these values are provided already. You have to just put the values here. In case of electrode potential of the oxidation half cell, it is minus 0.76, because oxidation is carried out at the zinc, and zinc is having value minus 0.76 volt. You can correlate this data with the table provided in your textbook. Okay, so by calculating this negative and negative sign become positive, it will give plus 1.10 volt. That is the output voltage. Now some of the terms which are related with the danger cell. The first term is redox couple. So basically a redox couple is the oxidized and reduced form of an element. You can see here, oxidized and reduced form of an element. So redox couple is Zn2 plus and Zn. As similar, Cu2 plus and Cu is called redox couple. It's called redox. Okay, so what about the redox couple? Redox couple is the oxidized and reduced form of an element, that is called redox couple. So the next, electrode potential. There is two terms. One is cell potential and one is electrode potential. So what about the electrode potential? Electrode potential is the potential difference between electrode and electrolyte. I repeat once again. Electrode potential is the potential difference between electrode and electrolyte, while cell potential is the potential difference between cathode and anode. That is the basic difference between electrode potential and cell potential. So the next, the standard electrode potential. There is a little bit difference between electrode potential and standard electrode potential. Okay, in case of standard, we have to put a note sign here, E note, like that. So standard potential, that means that measuring of this electrode potential is carried out at standard condition, like temperature 298 Kelvin, okay, and 1 atm pressure, that is the standard condition. Next is salt bridge that we already discussed. EMF is electromotive force. Okay. So this is a worksheet. So you have to complete this worksheet. I already provide the answers in our next slide. So I discuss one by one each and every question. First question: Daniel cell is a type of gas. It is a type of electrochemical cell. Next is output voltage of Daniel cell is 1.10 volt. Question number third: Salt bridge connect two half cells. Guess what? Internally. Salt bridge connect two half cells internally. Reduction. Question number four. Reduction is always carried out at cathode. Oxidation is always carried out at anode. In electrolytic cell, anode having positive charge, while in case of electrochemical cell, anode carry negative charge. As a lone, left oxidation, anode and negative. These are the answers. Okay, so this is all about today lecture. We will continue this chapter with our next lecture. Thank you. Be at home. Be safe. Have a nice day. Okay.